All right, the person is prone, and I'm gonna superimpose the cardboard sacrum on here so that I can explain what it means by one-sided flexion. So one-sided flexion, let's say that it's the right-sided flexion. What happens biomechanically is this right side, the sulcus, so the sacral base here, so this is sulcus, and at the edge of the sacrum base is the sulcus. So the right side sulcus here is going down, so it gets deeper, but at the same time, this ILA, the same side ILA, goes like that, so it gets inferior. So that's the flexion, one-sided flexion. Now, let's talk about one-sided extension, but now happens on the left side. So extension is this. Left side of the sacral base here, which will be the left sulcus, will actually go up this way, and this ILA will go up superiorly. Now, don't you find it as weird? Because right side flexion, left side extension looks exactly the same. Now, how can we differentiate this? And that's why we do the Sphinx test. So in the Sphinx test, what we do is that we ask the person to extend the lower back. Then as we extend the lower back, what should happen is that sacrum should flex. So there's a reciprocal motion that should happen. But now let's say that right side was one-sided flexion, in one-sided flexion, and then we're trying to flex. Because this is a flexion-based lesion, which means that it likes to be in a flexed position, it will even out because everything will go down into flexion because it can move into flexion. Well, to be exact, this was already deeper, right? And as this gets deeper, this can catch up because there's no lesion here. This is not stuck. So that's why you see that DILA gets level, so the DILA disappears if it is a flexion-based lesion. Boom. Flexion-based lesion, DILA disappears, right? And now, let's say that this was actually the left-sided extension. So in neutral position, it looks exactly the same as the right side flexion, right? It will be like this. This is up, this is a superior, so as a result, this will look like this is down. But now we do the Sphinx position, Sphinx pose, and now this thing doesn't want to flex because it's stuck in extension. So what will happen is that this will go down, but then this doesn't go down, so this DILA actually gets worse. Yeah, so that's what it means by extension-based lesion. So hopefully this makes sense, and if you think about it, this is actually quite simple. We just need to know that when one-sided flexion happens, the sacral base of the same side goes down, so anteriorly, so if this is anteriorly, but at the same time it goes so inferiorly, so it becomes DILA. Yeah. And extension will be the opposite. This will go posteriorly, and this will go superiorly. Yeah. And now, what it means by the oblique axis? Now, oblique axis means this. It is rotating around the oblique axis. If the oblique axis goes from left sacral base to the right ILA, we say that this is a left oblique axis. And around the left oblique axis, the sacrum can either going this way or that way, right? It can rotate both sides. So, for example, the lesion occurs on the left axis. If the sacrum rotates to the left on left oblique axis, we call it a flexion-based lesion. Axis of rotation, direction of the rotation, they are same. They are flexion-based lesion. When the flexion-based lesion happens, look at that. So left oblique axis and flexion-based lesion, what happens is that the right side sulcus gets deeper, and at the same time, left side DILA depresses, like that, like so. That's the flexion-based lesion, happens on the left oblique axis. Boom. Now let's talk about the oblique axis extension. So now I'm going to show you the extension around the left oblique axis. It's going to be that way. And when that happens, this looks like it's getting deeper because this is coming up, but at the same time, this is coming down. I'll do it again, like so. So now think about this. Left oblique flexion, which means left rotation on left oblique axis, right? And the right oblique axis extension, which means left rotation on right oblique axis, they will look very similar in neutral because both will have deep sulcus on the right side and DILA and the left side, right? They look very similar. So now we do the Sphinx test to differentiate that. Remember, Sphinx test is testing to see if the sacrum wants to stay in flexion or not. So if it is a flexion-based lesion or not. So we do the Sphinx test, and if DILA disappears, then it's a flexion-based lesion. So it's a flexion on an oblique axis. What that means is that so flexion on an oblique axis, to simplify and memorize it, to simplify this, flexion means that direction of oblique axis and the direction of rotation is the same. Yeah. And as a result of a Sphinx test, if the DILA remains the same or gets worse, that means it's extension lesion. Extension lesion means that the direction of oblique axis and the actual rotation is the opposite. So that's how we simplify it. And at this point, I know that there are so many people who still think that, oh man, you just complicated things more by trying to explain this oblique axis thing. Now understand, that may be true for a lot of people. So for this reason, now that I explained all the biomechanical thing and I believe that you understand all that, now I'm just gonna ask you to remember this like a formula. If it is a flexion-based lesion, oblique axis and the direction of rotation is the same. So meaning that if it is a flexion-based lesion that happened in the oblique axis, and we found that deep sulcus was on the right side and that DILA was on the left side, because this is a left rotation, this is left on left torsion, meaning that left rotation that happened around the left oblique axis. Yeah, hopefully this clarifies things. And if it is extension-based lesion, and we found that in neutral that the deep sulcus was on the right and the ILA was on the left, then this means the axis of rotation and the rotational direction are the opposite. So we know that it is a left rotation because deep sulcus was on the right side. But it's not a left axis, it's a right axis. So right axis, extension on the left side. And so actually this didn't get deep. This was extending, this was actually becoming superior. And that's why we're feeling that this felt like deep. Hopefully that makes sense.